All right, so at this point, we're going to move forward with the experimental component of our procedure. For this week's experiment, maybe the most important piece of glassware that you're going to be using is this one right here. This is called a volumetric flask. Now, what you need to recognize about a volumetric flask is it doesn't really have any markings on it. It's got kind of an odd shape to it. It's round and it has a flat bottom to it so it can rest on a surface without toppling over. But what I want you to recognize, and this bulb down here usually lists the volume, as it does with this one. This is 100 milliliters. On the neck, you'll see this very fine etching, and that etching denotes 100 milliliters. So effectively, this piece of glassware is good for collecting 100 milliliters of a solution, and that's about it. If your solution level is below this or above that etching, you really have no idea accurately what volume is in there. If it's below this etching, you know that it's less than 100 milliliters. If the solution's volume is above that, you know it's more than 100 milliliters. But is it 101, 105? You really cannot figure that out with this piece of glassware alone. Now, this piece of glassware is very effective for making solutions. And we're gonna make a total of 3 different solutions. We're going to make sodium chloride, or a sodium chloride solution, a sucrose solution, and a calcium carbonate solution. We're gonna make these 3 different solutions, and we're going to try to classify each one of them as an electrolyte, a weak electrolyte, or a non-electrolyte. And what we're going to be doing is making those solutions and determining, does that solution conduct electricity? We're going to be doing that in this piece of glassware, but then we're going to be transferring with these right here, these bulb pipetters, these transfer pipettes. We're gonna transfer small volumes into our 24 well plate. When you transfer it into that 24 well plate, well then you can just stick the ends of your lighting apparatus into that solution and determine whether or not it conducts electricity by sending it through that battery. So can a current go from the battery through the solution to the light and be completed at the other end of the battery? All right, let's go ahead and stop right there, and we're gonna get started with part 1.